And I just habitually trying to record stuff, even if it's terrible. Okay, so this is, I just want to summarize a pull request that I did with some work with Andrew that I've ended up calling lifted operators and modularity, which makes it sound substantially more fancy than what it actually turns out for users. So here's a motivating example. We're going to run a function which does some kind of processing, function A, and what it returns is quite a big data structure. And then we have another function B that's going to process some part of that data structure. So what you would do is, in normal Python, you would run function A and that's going to return this dictionary, and then you just pull out the piece you want and feed it into function B, and that gives you your result. So you might ask, why do these two functions, why aren't they directly composable? Why have they got this awkward API? Why don't you just rewrite these functions? And it's really a sort of modularity thing. So this is where Andrew comes in, where he's building libraries for other users to use, and those users put the pieces together somehow. So you can imagine the library author wrote these, but the user happens to have chosen to compose them that way. So in other situations, what the user would compose would be different. Okay, so there's now 3 players in here. There's Parsl, or the Parsl developers. There's this library developer, which is Andrew, and there's some other end user who is, so Andrew is writing this, and the end user is writing that. So that's why why we can't just fiddle with the APIs of the two functions. So in Parsl, if you want to do this in Parsl, here's a fairly obvious way. You turn A and B into Python apps by sticking Python app on the front. You invoke A, you get a future, you wait for the result, you pull color out of the result, and you launch another app here. And that's a kind of obvious way to do it. It isn't a very good way to do it because it turns out to be quite harmful to modularity, which I'll talk about now. So if you imagine these apps A and B take a day to run, right, just some long time, and I'm going to call it A. When you invoke A, the code starts here, and then you say A.result, and this call is going to block for 1 day, okay? It's going to block until tomorrow. And then when A.result returns, we can pull out the color value and launch at this second app. And that's going to take another day. So the start-to-start runtime takes 2 days. But the important thing is that just to execute this bit of code, it blocks for a day here, and then, blocks for 1 day here, and then it blocks for another day here. So when I say that's considered harmful to modularity, what I mean is, what about if I do this in a for loop? Okay, so I do this, I'm going to go through several different samples. I'm going to launch A on the first thing. I'm going to wait a day for the results. Then I'm going to launch B. When I get the result there, then I'm going to reiterate my for loop. And on day 3, I can start doing A on the second entry. So having these results in here has really screwed up the concurrency, right? Really, I would want all of the A's to be running concurrently, and all run 1,000 nodes that take 1 day of real time for my 1,000 concurrency. So another obvious solution is, why don't you just build your own custom application-aware task scheduler instead of using a for loop? That's quite complicated. Parsl is meant to make it so you don't have to do that kind of stuff. If you look at the work Logan's done this dynamic steering stuff, and like, it's cool for what it does, but it starts giving you a feel, I think, for if you're starting telling users build all this complicated scheduling stuff that's paying attention to stuff. I think it's also a good warning to not try and do that unless you really want to be doing that. So we can structure this in a different way. We can get rid of that. The only reason we had to wait for the result was to get the bracket, use the dictionary notation, this bracket color thing here. So what we can do is sort of lift that up into its own app. And now we can do everything in future land. We can submit 3 futures, 1, 2, 3, submit them early on day 1. Mostly this one's just going to sit waiting on dependencies, and then it's going to look up color. This one's going to sit on dependencies for a long time and run. So the end-to-end real time is still 2 days. But this for loop iteration ran really quickly here, ran pretty instantly, which means we can now launch every iteration right at the start, and we unlock a lot more concurrency. Yeah. So all I did was make a more Pythonic syntax for that get color helper. Okay, if I go back here, this get color helper up here, all it does is it takes a dictionary and returns color from the dictionary. So wouldn't it be nice if you could just write that? Okay, use a dictionary index syntax that if you're a Python programmer, you kind of know what that means. Okay, so that replaces having to make this custom app. And that's basically all PR 2904 does. The implementation's pretty simple. What it does is it feeds in when you do this, it gives you a future back, and it puts in this implicit dictionary lookup as another node in the DAG. So because it's another node in the DAG, it gets scheduled by Parsl just like everything else. Okay. So here's an end. The value of these expressions, right? Forget the concurrency. If I have a future that returns a dictionary and I wait for the result and I look up X, that's the same as having a future, asking to look up X on it, which will give me another future, and then waiting for the result. So you can sort of commute result and X. Okay, and the difference is, in the bad side, that's a 1-node workflow, and you have to wait for the workflow to end before you can do anything with the result. But this is a 2-node workflow. There's F is 1 node and lookup X is another. And we've got the result all the way at the end, which is good for, that's the key thing for compositionality, getting results way at the end. So what this returns, if you imagine X returns an int, what this returns, this doesn't return an int, this returns a future that when you ask for the result will give you an int. So that's what I mean by lifted operators. What we've done is lifted this array lookup indexing operator, and we've lifted it from being a Python expression into being its own Python app that lives inside the Parsl DAG. We also did it with dot. So when you say my object dot my attributes, that lifts in basically the same way, and we did that. There's also scope for other operators, which we haven't done. So the arithmetic ones also make sense. Not all of them make sense. For example, len doesn't make sense because it's always got to return an int right away, and you don't have that information available. So the summary is just, we made this PR, it's merged. It lets you use more Python style syntax while you're constructing your DAG. And that really tries to make modular workflows easier to read and write. And that's the end.
No, that's fantastic.
Yeah, Andrew, I don't know if you have any commentary to add about your take. Like my perspective is a very functional programming language take, and maybe you have.
No, I think you really nailed it, and I appreciate very much how willing you were to do this and put this together. Like you said, the implementation is relatively simple, which is always good, but it is really nice to see. And yeah, I just wanted to say thank you for that. For me, like I'm developing a library of tools that you said correctly, other people will maybe compose in certain ways that I don't know how to predict. And so that was definitely a major factor. The other factor is that I think there's just something elegant about having this approach of, you write your Python function, and hopefully with Parsl, you don't have to change all that much when you go to using Parsl. And, for new students or new users, things like futures can be a little bit complicated, even though we take them for granted. So anything that can help kind of bridge that gap just conceptually, I think is very helpful from a new user perspective too, even though that's maybe not the highest priority. It's still helpful. So yeah, I just wanted to take a moment to say thank you for that.
Cool. I guess some of the stuff Sander is doing is kind of fits in that same space of trying to make modular libraries, right?
Yeah, I think it's very, very, very overlapping use cases there for sure.
Mm-hmm. Cool.
Yeah. No, this is really cool.
Really cool. Do you know like what's the what's the level of coverage we get from just having the brackets and the dot? Have you like looked at other applications where you've like seen this sort of pattern, or I'm just trying to figure out like how much we expect this to go, how far this would go with just these accessors.
So there's this general lifting concept, and join apps came from the same space, right?
Right.
And the perspective there is, I only want you to call dot result at the end of a workflow.
Yeah.
Right. So if there's a dot result anywhere apart from the end, ideally we can figure out some way of not doing that. So join apps are like a complicated way of doing some of that stuff. I think this is a much simpler way that maybe it's just going to change how people can write their code. It doesn't give you anything that you couldn't already express, right? With this awkward accessor function, it just makes it prettier, right? It's easier to understand you're doing a dictionary lookup here because it looks like a dictionary lookup.
Yeah.
I can also provide a little. Oh, go on.
I like the inclusion of get attribute to, or the attribute lookup. So I'm thinking on like a pattern one often sees in SciPy, where a function will return a tuple, where the first thing in the tuple is always like what you care about, then you get diagnostic information out of it.
Mm-hmm.
So the ability to lift the result out and pass that to the next step.
So you're always wanting to discard that second parameter.
Yeah, I mean, you could write another function that takes the whole thing, and all it does is save that to disk or something weird like that. Yeah. And you could just express that as another option, build it into the same workflow, and get the same single future coming out of the end. Mm-hmm. I think it fits. Yeah, you could still. Oh, go ahead, Andrew.
Oh, I was just gonna say that's the kind of challenge that I run into a lot. Where like then if you just made one Python app that took that whole tuple, then you're kind of writing the function such that it's reliant on the data structure from SciPy. And if it was doing some mathematical operation, you'd ideally want it to be independent of the data structure from SciPy. So it's like, oh, you just want to have this discrete unit of work that's independent of where the source came from. And then you can't do that unless you use something like this lifted operator approach, which I think that was often where I was arriving. This issue.
Yeah, one question. So with the how does the dot play with the fact that there are already some other attributes on the future, like dot result to
if an attribute exists already, it doesn't do any special handling.
Perfect.
So the special handling is essentially where previously it would return an attribute not found error. It now always returns a future, and later on you might get the attribute not found error out of the future.
Sure. Interesting.
Yeah.
So once the future resolves, then the error will show up.
Now,
the data that came.
And that's the same reason why you can't use, basically the same reason why you couldn't overload len, for example, because I don't know enough now to return. Len wants an integer, and I'm like, I can't give you an integer. All I can do
is still catch. Eliminate a lot of things that would otherwise cause people to write those special lifted functions. Mm-hmm. And I was thinking while you were talking if I could come up with other dumb ways of doing it, and couldn't come up with anything. Like callbacks was my first thought.
Yeah,
but those don't return you a future.
Yeah, I mean, all of getting into callbacks, I think, is for it's the same level as what I said about you doing your dynamic steering, right? It's nice to have that an option, but it's not a thing that we should be telling people they should be doing, right?
Yeah, if their solution involves messing around with threads,
yeah, right.
then,
And so callbacks also hit that same space. So if you're just lost in this stuff, should like Andrew said, this stuff should look like the original Python expression as much as possible, just magically parallelized. Like, I think that's a really good syntax goal to express that right way, right?
Yeah, and keeping people from having to write a special wrapper over their library to make it Parsl-wise. Avoiding that. More ways we can do to avoid that, the better it seems.
Yeah.
I'll also chime in to just say another plug for why I think the Parsl community is great here is I've been before I decided on Parsl, I was trying out a bunch of different workflow tools, and I had this specific issue on several of them, and I opened up issues to chat with folks about it. Parsl was the only one, and Ben in particular, you of course, were the only one that was receptive to the idea, and other workflow tools were like, absolutely not. They're like, we want them to know that they're dealing with futures. They need to handle this on their own. And I was like, okay. So I think that just says a little bit of something. So just a little comment there.
Yeah. I mean, some of that is just like my non-HPC stuff is I'm very interested in programming languages and embedded programming languages rather than building workflow systems. And so there's a different angle of how I approach some of this stuff. All right. Good. Hello, Kyle.
Still stuff. Is there anything we can do to help the PR go through? Or...
It's done. It's merged.
It is?
I think.
Cool.
I
kept the process going by keeping my nose in it.
It was such a tiny little bit of code. It's like 5 lines or something ridiculous. I was fairly... The only weird thing I'm expecting is that if you now request a dictionary entry or an attribute on an app future that isn't going to exist, you're still going to get an error, but it's going to be moved around in time. So we just need to be aware that people will see slightly different errors in that situation to how they did before.
That sounds cool.
We've got to wait. We've got to wait to the future to tell them it doesn't exist. But yeah, cool. All right, I think
I see the code. It is as you said. It is pretty cool.
Yeah, it's literally that. It's just literally syntax for that get attribute helper.
Yeah, it's exactly that. It's like when you do the get attribute, you like wrap in Python app.
Yeah. Cool. All right. Let's move on.